How's everyone doing? Thank you for coming out. Really appreciate it. We are going to do 3 lightning round tech talks, and then after will be a Q&A session. Feel free to, we're going to have some time at the very end to ask the speakers some questions if you have any. And then obviously the Q&A will be with just a couple engineering managers here. And then, yeah, our first speaker is RJ. So I think he will be here shortly. Give it up for RJ. Yeah.
There we go. Hey, everyone. Hello. I'm really excited to have everyone here. I'm here to give a little tech talk about how we built scooters in the Lyft. How many people are familiar, actually, with the scooters they've seen on the streets? Actually, who hasn't, really? Like, I don't know, maybe you're lucky. I don't know. But we launched scooters in Denver and Santa Monica recently. I was really thrilled. It was super, super exciting. And we just learned so much along the way while building this that I figured I could do a quick talk on this and kind of go over some of the stuff we did. So who am I? I'm RJ. I'm an Android dev here at Lyft. I started doing Android pre-Froyo, but I actually, now that I think about it, it's really disappointing. I joined the Android world right after Donut, even though Donut's like my favorite food. So there was kind of a missed opportunity because I joined doing Eclair, which we all know is like an inferior donut. But since I've been here, I've been focusing a lot on transit and mobility and all these like really cool ways that we could get you where you want to be. And one day, as part of this, a director came up to me and they're like, "Hey, I got something to propose to you. We've been working on this scooter thing." And so they didn't say it quite so eloquently, but I want to recount it as a haiku. It goes, "We all want scooters. Android, iOS, server. From scratch, 2 months, go." And I'm just like, oh yeah, this is super cool. And I started like writing prototypes and you know, Pierce, wherever he is, he was with me and we just rapidly hit the ground running. And then I kind of got terrified when I started to realize what I was getting myself into. And I remembered I've been here before. I've been in situations where you're right at the start of a project, you're really not sure what you're doing, you're excited for every technical challenge, but you always have to stop, take a deep breath, and I stepped back and I went, okay, what's the actual problems I'm solving? How do I focus on the right problems right now at the beginning? And so what I've always learned is people problems are the very first thing you have to think about, and they're really what's going to guide you through a really complex, fast-paced thing. And so the people problem, that essence of what we were solving for, was trying to make that magic moment where traffic's horrible, or you just need to get somewhere, you spot a scooter, you whip out your phone, you jump on that scooter, and you fly away. Just that magic, seamless moment. And we got everyone excited about that idea. And that was so helpful because after all these technical prototypes, it meant that instead of having this really solution that seemed endless and unbounded, the problem itself just naturally started to have boundaries to it. And so from an Android perspective, it really became clear what the boundaries were, which is like, have to be there the moment they want it, which means I can't make them download anything. It means that I have to keep this seamless as part of the Lyft experience. I can't ask them to add a new credit card or anything like that. It needs to be predictable and easy to find, and we have to always be like, you know, at the end of the day, I have 40 other people on the Android team, and if I make their lives miserable along the way, I'm not a very good coworker. And that gets me to the most important point, which is you're never allowed to break the existing app. So now that I step back and I was thinking, like, can I really, really do this? And it really kind of got a little terrifying, because we were building one product in 2 months, and there were these 3 big realities I was going to face. And when I say we were building it in 2 months, I mean everything: getting the scooters, getting the hardware, getting the firmware, testing it. All this was being spun up at the same time, the server people. And that meant that just everyone was running towards the same direction, but I didn't really have anyone to lean on, which meant that I really had to be more than just a normal Android developer. I really needed to step into other roles. And that's kind of what led me to the first reality that I think we all face as Android developers, which is you're never really dealing with final designs. As much as you want them to be final, they never will be. So my first job getting into this was we had to be real about it, that we weren't going to get these final designs of what to build right away. So we started to think, how do we get in the minds of our coworkers? How do we start to understand how we're processing the problem? And then we're all just looking for something we could all agree on, that North Star, and we came up with what we thought was our golden path. We thought was like the core, most agreed upon part of what we were going to build. And this all led back to that initial vision about the seamless experience. And this ended up being a crucial part of everything we were building. Because right after that, we took every bit of knowledge we had in our heads about how we were building apps already at Lyft, how we were piecing all these parts together, and we knew every bit we could already reuse. I think Kathy here on the Lyft team has built the Lyft product language for Android, which means we just grab components that are gorgeously made, that are accessible, that have loading states, that have all the tough things that slow you down as a developer, and we knew we could pull it out immediately. We also had, they asked, oh, we really want to have a driver's license scan. Do you think you could do that? And I don't know how to do that. But it turns out we already had this as part of our driver experience. And because we had invested in this component framework, I was able to just, well, I didn't do it, but we asked a coworker to jump in, and they just literally yanked it out and put it in our experience. So these easy wins let us help define what these guide rails were to what we were building. And we were able to communicate that back to the product team. So after we had all that, we kind of got a rough idea of what this golden path was going to be, and we were able to put a marker in the sand and say, this is a best guess right now. Things can change within it, but this is what we're going to run with. We printed it on the wall, we posted it up, and we pointed at it, and it really helped us all drive towards the same thing. Okay, so now we got this product thing locked down, but we still have to build it, and it's a web service. And that leads to the second reality I was facing, which was, as much as I just wish the server was done, and then I'll do my work after that, that the server work is really, they're going as absolutely fast as they can, but it's not enough. And we had to just constantly look for ways that we could unblock ourselves from them, but that didn't mean like moving away from them. We still needed to be right there with them, just physically next to them, but not depending on them. So that just meant we had this printed out golden path on the board. We knew exactly what we were building, but we needed to translate that into what would that mean for the server and the client. And so that meant, how elegantly can we represent this with as little code as possible? It actually wasn't a 100% match one-to-one with the things we had printed out. There were times when we realized, actually, that's a duplicate of what we were going to be needing to represent. And that really helped us cut down on the number of complexities and let us build extra fast. So then, after that, we actually were able to spec out the API really quickly. Well, I mean, 144 conversation comments quickly, but it let us rally around something really, really fast. And because we were able to rally around that, we were able to just start building the UI immediately with the expectation that the server is going to return. And then quickly following that, we just made sure that every little bit of our code, we just, as far down as we could until the very last API call, would be a fake, would be a mock, would be something that all we needed to do once the server finished their work was just to replace that line of code. Of course, that doesn't always work the way you want, but that was the hope. So then the third and final reality that we were facing was we were doing all of this when we had no scooters yet. We had scooters, but there was none of the guts in them. And so really, really early on, right when we were doing all these designs with the designers, right when we were doing the APIs with the server engineers, we're also sitting down with the firmware engineers. And we're going, okay, you will have a scooter. What will it do? What are some of the basic things we can expect it to be? How is it going to interact with the service at a really high level? And then trying to get as much as we could and how that would translate to that golden path we had agreed on. Once we were able to do that, it actually turns out it wasn't that complicated what that would look like to the phone. There's a lot of complexity all throughout the system, but from my side of things, I could boil it down into just a couple really simple states. And then all I had to do was just pray that I could abstract away all the rest of the complexities. And if I couldn't, then hope the server people could. And then the very last bit of it that really stitched this together was we were able to just fake a scooter by running a little Python script to be able to send the commands that a scooter would be sending and listen to the commands that a scooter would be sending. And this is my only serious Python contribution to the Lyft codebase. It was truly, truly awful because it's been 10 years since I've done Python. But this was really amazing because it really helped us end-to-end test this entire experience without actually having any scooters. So after all that, we think we have something working, but I'm kind of blind to these problems myself. So we really quickly had to look around, all of us, anyone around us, and we had to ask, how can we get them to help? And that often meant just buying them donuts and making them coffee. But a lot of times it meant going out with them, showing them the product, finding ways that if they didn't understand how the script worked, make it more accessible. We just focused on how to get the QA people, which joined midway through, the ability to go work on it and contribute as much as they could. And probably the most important thing along the way here was we were still building within all of Lyft. We still had to try our absolute best to not make enemies out of our coworkers. And so the release manager, we were constantly asking her to cherry pick things for us. And this was like, I truly felt like I was ruining her life the amount of times at like 7 p.m. or 10 p.m. I'm like, I need this cherry picked. So I really found that, like, what's her favorite thing? And it turns out it was macarons. So when I was coming back from a trip overseas, I made sure I saved some treats for her. And I sincerely hope she appreciated it. But yeah, I mean, it also boiled down to, like, we accrued tons of technical debt while we were doing this, and we genuinely documented that one day we will get to it. Yeah, my coworker is in the room now, so sorry. But after all this, after I faced all these realities, after we had, dealt with those, we still had the honest truth, which is these parts don't fit on the first try. And so we were sitting there in a conference room, it's 7:30, 8 o'clock at night, and we are debugging like mad. And the wires are sticking out of the scooters. And I just remember that the server engineer, nothing was replying correctly. It just kept coming back as zeros. And he just took the entire AWS fleet, dropped it down to one single machine, and just hard logged into it and started editing the Python on the fly right there. And that turned out to be critical because otherwise we'd have to wait 15 minutes or an hour between every deploy cycle. And the little things like this went from an integration that could take a week to an integration that took one night. And that night, when we finally got that button to work and the scooter to change colors and I almost crashed into the wall right there, was just like the most glorious moment. And it was just in the nick of time. We had a giant countdown timer at our office glaring at our faces every day we walked in about how much time we had left, and we had just barely made it. So after all that stress, after all of that anxiety, when we actually went out on the field on the first launch day is when just everything made it feel like it was worth it. From dropping off the first scooter, to going and finding the first person driving by, to going watch the first person open up the Android app, because at that point, you'd never seen anyone use it publicly, and you're like, oh, is it an iOS? Did iOS just work? You see the Android phone, and you're like, oh, they're using my code. I came across groups of people trying to use it, and it wasn't showing up for them, so I throw open my laptop right in the middle of the street and start debugging it with them. Turns out they were in the control test group. Yeah, right? And then to celebrate, I bought everyone donuts. Yeah. So, yeah, if you're ever in Santa Monica or Denver, please go try this out. Yeah. How are we doing this? Should I? Okay, well, next up is Artem. No, who's? No. Okay, all right. I'm just going to hand this over.
Okay. Thank you, RJ. It was really cool and exciting. So today I'm going to talk about growing your application from hundreds to thousands and to millions of users. You might work in small startup, or you maybe build your application by yourself, or you maybe work in a big company, but you would be probably interested about features that we do in Lyft to grow our application. But before we begin, let me introduce myself. My name is Kateryna. I'm working in passenger growth team, and this is my team. And today I'm going to talk about features that we ship together. So we're going to talk about Lyft rapid growth and how we do it, what we do for new users acquisitions, and how we simplified our sign-up flow by using different Android features, and what we do for retention and engagements. Also, we'll talk a little bit about accessibility and how we ship features to millions of users. So we started Lyft 6 years ago with one simple mission, is to improve people's life with the world's best transportation. And we thought, okay, how are we going to measure it? How are we going to measure our success? And the main metric that we are using is weekly number of rides. And this is a number of rides that we did starting from 2012 till now. And could you guess how many rides we completed totally together, like total number of rides? Any guesses? We completed 1 billion rides last month, and we are so happy about it. And we had a really big celebration. So how we do it, how we scaled our application so everybody uses it. First of all, we treat each user differently, and we package our users in different groups, like new users, loyal users, churned users, and people with special needs. And I'm going to talk about all these groups of users separately. So for new users, what's the most important thing? They are new users, they never use the application. So the first important thing is when they install your application, and then they onboarding or sign up flow, and then the first experience that they have. What can prevent users to install your application? Today on Google's conference, they announced these numbers that conversion rate decrease as application gets larger. So this is official Play Store Google numbers, and if you build a really big application, the conversion rate of installs gonna be low. So you need to think about if you introduce a new third-party library, or if you add a really big video to your application, you need to think about it. And you need to remember that every 6 megabyte increase to APK size decreases install conversion by 1%. Okay, let's assume that people install your application and they go through onboarding or sign-up flow. In Lyft, we use a phone to authenticate users, and we send SMS tokens, so users have to enter the token to confirm their phone number. And we thought, okay, how we can simplify this process? We also noticed that 4% of new users drop off at this verification stage because they have to switch between SMS and our application. And sometimes they enter wrong code, so there's a really big chance of mistake. There's Android solution for this. You can use automatic SMS verification with SMS Retriever API. You can just use, check out this link, how to integrate it to your application. And by the way, it also doesn't need any permissions, like extra permissions, to read the SMS. So it's a pretty cool feature that you can use in your application too. The second thing is you might ask your users to enter their first name, last name, maybe other information like email or profile picture. It's extra work and users might not like it. So it would be cool to have one-tap solution for this. And there's Android solution. Actually, it's a Google Credentials API. So if you use it, you can just show Google account picker to users, and they can just tap their Google account that they want to use to send into your application. And you can get all information: first name, last name, email, profile picture, and even password. So it's very nice and easy, and users don't need to enter lots of things. But let's say if they don't want to use their Google account or they don't have it, we noticed that if users enter their email manually, they do lots of typos, like gmail.com or gmail.com, which is hard to notice. But for us, emails are very important because we send our write receipts to users' emails. And we were thinking, okay, how we can do, how we can help our users to help with this. And we decided to use Google autocomplete suggestions. You can also use it in your application to complete domain names, or you can use it for anything else. You can just provide a list of, let's say, domain names, and you can use it. Also, really nice feature comes in Oreo. It's autofill framework, which is really nice because, if users need to enter their payment method, like credit card, they can do it with one tap. And you can also use it for name or other fields that users need to enter. To optimize your application to support this autofill, you can check out this link too. Okay, so if we already have new users, they onboarded, they probably tried your application and they like it. In a happy scenario, they become your loyal users. And you need to make sure that your loyal users, they also use your application. What we do in Lyft for our loyal users, we sell different ride passes or subscriptions. And we're happy to share that we just launched All Access Pass for everybody. Everybody can purchase it. With this pass, people can save money and also make more rides, which is good for us and good for users. We also have referrals feature in our application, and our loyal users are the best referrals. They also get bonus if they refer a friend. And these are the best sources of increasing new users sign up. But let's say if somebody had a really bad experience with your application, it could happen, right? How to get those users back? How to ask them to try it again and get them love? So we do different promotions and coupons, and but the main problem for us is how do we notify user if they don't use our application? How do we notify them if they have a promo or coupon available so they can take a ride again? And for this, we use different notification channels like emails, push notifications, SMS, or badging the application icon. As you probably know, in Oreo, they have little dots. Once you send a push notification, you also will see a badge next to your application icon. But for older devices, it doesn't work. But there's a workaround. If you check out this library, you can use examples and integrate it in your code and send a silent push, and you will see a badge for your application that will show there's something for you that you need to take a look. Also, we make sure that our Lyft application is accessible for everyone. And as RJ mentioned, we developed a Lyft product language, which is like a set of rules, standards, and different components that we use in our application. And we make sure that we have specific target sizing, like minimum 40 ADPs. We have color contrast that has specific and corresponds to specific standards. That our application also has screen reader support, and users can use Android TalkBack to actually request a ride, and this is really great. The next secret sauce that we use is our development process. And we use ship, learn, reiterate rule. It means we ship feature, run an experiment, make sure that it's successful, because you could have a great idea, but maybe users don't think so. So you need to run every feature, every new change under experiment, and then learn, is it successful or no, analyze data, and think how you can make it better, how you can improve user experience. But you also need to treat different users differently. For example, if you ship a feature for new users and they've never seen it, they've never tried your application, they might react differently. Loyal users, they might already using your application, and they might be very conservative if something changes. So analyze results for different groups of users differently and think if it's successful for both groups, actually. Just interesting fact, how by shipping different experiments for different features, how Lyft UI looked like in 2017, and how Lyft looks right now. So as you can see, it changed dramatically, and we run experiments for every single color or copy, or for every screen, to prove that it's working. The last very important thing that you need to worry about is quality. And I just want to remind everybody that the relative cost of fixing a defect on after your feature is released is very expensive. So this is if you fix a defect during requirements, if you realize that this is not something what users want, it's much cheaper. If you find a bug during development or code, it's a little bit more expensive, but still not that much. But if you release something that user doesn't want, it's going to be very expensive. So in Lyft, what we do to avoid this, we do user research before we begin any feature. We do design review together with the team and together with other users. We cover our code with unit tests as much as possible. We also have integration tests for system integration tests. We also do user acceptance testing together with our product managers and QA team. And we actually have espresso tests for UI testing as well. And we always verify that our feature is successful once we release it. Thank you. That's it. So let me introduce Artem. He's going to talk about Kotlin.
We good. Yeah. All right. Cool. So I'm Artem. I work in the client tooling team. This is a team that maintains builds and all that for Android and iOS, and I'm on the Android side of things. Yeah, I don't have much jokes or something, and I haven't timed my talk. We'll see how that goes. So I'm pretty sure some of you already work with Kotlin, some of you are planning to, and this is our story from the tooling perspective. There is a lot from the people perspective, but not gonna really be covered here. So, come on. No? Okay. Oh, cool. Yeah. So let's start with why do we think our project is kind of large? Not the largest, but kind of large. So, okay, cool. Next. All right, so if we just clean our repo like last week, that would be around almost 20,000 text files, around 13,000 Java files and around this week is definitely 700,000 lines of just Java without comments and everything. So that's pretty large. After a regular build, for some reason, we get 63 million lines of Java code. I hope I'm really wrong, but I counted, so yeah, I blame Dagger too. I need to look at this. And we have around 709 modules. This is, I think, today. Yeah, I don't know when people have time to write that out, but anyway. So this project is set up as a sort of monorepo, not like entire org is in this repo, but every line related to Android is in this repo. And pretty much we have two Android apps living in the same repo, driver and passenger app. And last week, over 50 people committed some code, like somewhere around 300 PRs were landed. Yeah, I don't know. That's pretty bad. Still. So our build setup includes two build systems, Gradle, obviously, and Buck. I think it's becoming a tradition to mention that on every tech talk, but idea is that all of our configurations are originally defined in Gradle, and then we generate Buck configurations from that with help of OKBuck from Uber. And obviously, we will need to support both of them to adopt to Kotlin, right? So what's the plan? Obviously, you need build support first, because otherwise you can write whatever language you want. It's not going to be included anywhere. And that means both Gradle and Buck. Then we want good IDE support. And it might sound obvious, like just use Android Studio, but we don't use Android Studio. We use IntelliJ, and the project is generated by Buck, not by Gradle. So it's kind of a bit more complicated than it should be. Then we obviously want static analysis for Kotlin, and in general, we want to avoid errors and mistakes that we have in our Java code base, because why would you repeat them if you're adopting a new language, right? Apparently, to adopt Kotlin, you actually want null safety in Java. The reason for that is because, well, this 7,100 lines of Java code is not getting anywhere anytime soon, and Kotlin code will need to interact with Java. And for Kotlin to be null safe, you either want everything to be written in Kotlin, or you want everything in Java to properly propagate nullability. Otherwise, you can still have like null pointer exceptions. We also want code formatting for Kotlin, because again, we don't want to repeat mistakes of Java and have like different styles of how people write it. And there is a big question about Kotlin annotation processing, because right now we use at least two daggers. Both Dagger 1 and Dagger 2, and all of them generate these 63 million lines of code that we need to interact with from Kotlin. But it's a good question, like if we want Kotlin to support this natively. So let's start with build support. For Gradle part, everything is almost good, because JetBrains maintains the Gradle integration for Kotlin. And almost, but immediately after we integrated Kotlin into our project, like a year and a half ago or so, we got like a year right away. That was probably due to our build being very parallel. And in Kotlin, what happens is that Kotlin compiler is so large that it wants to run as a daemon by default, as a separate process. And what will happen is that if you compile multiple modules in parallel, they will all talk to it. So that was gladly reported and fixed. And the point of mentioning it here is that, like, expect problems always, but idea is that JetBrains has really good support, and there is a UTrack tracker for their issues. So yeah, search and report stuff there. And also Kotlin is 100% open source as a language and tooling for it. So some stuff you can actually fix yourself, and yeah, just be done with that. So IDE support, actually, I forgot about Buck. Okay, Buck sort of works. Actually, we had to, so on the Buck side of things, JetBrains barely knows about Buck, and obviously they don't even care about integration for it, but So what happens is pretty much reverse engineering. Even though Kotlin is open source, it's not really documented well internally. So you like reverse engineer open source project to integrate it, like parts of its functionality into another project. And currently, it's mostly maintained by people from Airbnb, Uber, some parts of Square, and us. So like, yeah, we pretty much maintain Kotlin support and bug. So IDE support now. We use IntelliJ Community Edition because we generate our project with bug. It has multiple benefits for us right now because, well, Gradle is slow for us. So in general, IntelliJ IDEA 99% will work with Kotlin because since IntelliJ 2017 something, they included Kotlin plugin into IntelliJ, so it's like out of box now. However, in our setup, Bug generates IntelliJ project, so we did have some problems with that. It was breaking some stuff. So for example, here, this was supposed to be a package name, but it's not, right? It's like src main java.com. This is the package name now for IntelliJ. We obviously don't want that. And if you open the files in this module, like everything was told to be red because it's like packages don't match what IntelliJ expects. So it turned out Bug was generating wrong .iml files. And originally what we did is that we had this patched in our fork of Bug, but maintaining a fork of a build system is very painful, so I would not recommend that at all. Never, please, maintain a fork of a build system. So what we do now is that we post-process, like after Bug generates these files for us, there's a tool I wrote in Kotlin to post-process stuff for Kotlin, you know, and it uses RxJava and stuff. It's very parallel. So it's able to process all of our project files in like under a second normally, including parsing XML and changing it. So yeah, that's pretty much how we solved this particular problem, that originally it was fixed in the fork. Don't do that. So the big part of this integration was actually the static analysis. That was probably the largest if you take by time. And the setup of static analysis in our project before Kotlin looked like this. We had, and we still have, PMD for simple Java checks. You know, it's pretty good. I mean, nothing special, but it only supports Java. That's pretty bad. Then we had check style. I don't think we use it anymore, and it also only supports Java. And then we had Android lint, which internally is very powerful, and it actually can check pretty much everything. And nowadays it uses universal abstract syntax tree, which can process both Java and Kotlin and some other languages. So single lint check can work against both Java and Kotlin, which is amazing. And this is how it looks after we integrated Kotlin. So we still use PMD. I should really remove check style. I don't remember it being there. And on Android lint side of things, what happened is that I would hardly recommend you to adopt newer versions, pretty much of Android Gradle plugin at this point, but still. We also now apply it to non-Android modules. So for companies who look into integrating Kotlin into non-Android stuff, Android lint actually works with that, and it generates like beautiful HTML and XML reports. And yeah, that's actually kind of cool. And then we had already some custom rules, so we had to rewrite them to use universal AST so that these rules start to support Kotlin code and Java code automatically. And then new custom rules should only use UAST, and we were looking into introducing some like Kotlin-specific rules. But that actually failed for a few of them. I will try to explain why. Then this guy appears. So Yarapron, this is a static analysis for Java from Google. Why do we want it? Well, we want null safety in Java. And there is a project from Uber, as I told you. Or did I? Null away? No, that was a discussion there. So we integrated Yarapron to check nullability in Java. And there were some problems with that, but not with null away. And then there is also a couple of projects like Detect and KTLint or KLint. So we ended up using Detect. It's actually, I was against it, but it's actually very good. It runs really fast. It has really reasonable set of rules, and we pretty much applied most of them. And because we want to be pretty strict about how we use Kotlin, at least at the first years, maybe forever, I don't know. But idea is that whenever you have someone to review the code and there are opinions on how like the code is organized or what you can use in the code, that creates personal problems. If that's checked objectively like a tool, well, you can be mad at the tool, but at least you don't mad at some other people. So Yarpron. In our setup, it only checks for null safety. And yeah, as I mentioned, the main point of that is that because we have a lot of Java code to interop with from Kotlin, it has really reasonable defaults that are similar to Kotlin compiler. So it actually assumes that everything is not null already, and you only need to annotate what is nullable, which is exactly how Kotlin looks like. Like you place a question mark if you think it's nullable, otherwise you don't have to. It's also pretty configurable, and it runs as part of Yarpron analysis. So this is like a check for Yarpron. And recently they updated it and this update is like crazy cool. So what they do now is that they can analyze the bytecode of your libraries and infer nullability for those that don't have annotations in them, which is quite an amazing thing. So this is how it would look like. So for example, imagine this function accepts a nullable reference, right? And then you just try to call something on it, like to string or something. This will fail at compile time for us. It will be like the reference expression is nullable, so you need either a null check here or you need to remove an annotation, right? And this helps a lot for our project to make sure that we can still safely interop with Kotlin, and Kotlin knows what's going on with nullability. Obviously, 7,100 lines of code not going to fix themselves, so we do have around probably 4,000 violations of null away at this point. And we needed to come up with a strategy on how to integrate it without spending years to fix it. And so far, the integration looks like there is a file that says which projects Yarpron should not run against, which pretty much means that every new module by default is checked, which is what you want, right? You want to check existing code, or like new code, at least. And also then we fixed nullability problems in the core modules that are used pretty much everywhere in the app, so that we don't propagate this problem to new features that have to use some core functionality. So that was the strategy, and this strategy works pretty well for other tooling integrations that already have a lot of violations. Lint, on the other hand, would support it differently if that would be a lint check. Lint has baseline files, which are much more precise, and on the file level, they can, or even like on the line and function level, they can figure out the existing violations. However, not everything went smoothly, so we integrate Yarpron, and this is just a test project, but what I've seen on our project is very, very similar. We had our Gradle builds 3.6 slower, which is unacceptable because our Gradle builds are already very slow. And even with all the checks disabled, it was like 2.5 times slower, which is unacceptable because our Gradle builds is already very slow. And, well, that was unacceptable. So I had to ask our, who did I ask? Our IT guys to get me a license for Profiler so I could profile this. And yeah, it also consumed twice as memory. So yeah, not very good. This is the benchmark with multiple iterations, obviously. So this is a baseline. This is run against RxJava project. So RxJava is rather large. And like if you don't integrate Yarpron, it would take you like 4 seconds to compile your RxJava from scratch. If you integrate Yarpron with all the checks disabled, it will take you like 8 seconds. So like already twice as slow. And then like if you add more and more checks, it will take you like 3 times slower and so forth. So why, right? Apparently there is a white paper about Yarpron, so I had to read that to understand why it works like that. So the idea of Yarpron is that originally it actually runs as compiler. So it actually replaces your Java compiler and runs checks as the compilation goes, it checks your code. There are good parts of that, there are bad parts of that. The good part is that build system integrates your compiler, at least Gradle. Let's take Gradle as an example. Gradle will integrate your compiler incrementally so that if you compile something, it won't run again, right? Which is good, like, you won't run the ERPRON again. But yeah, there are some downsides to that too, because what if you want to use a different compiler? Now they kind of support that though. Turned out that ERPRON has a lot of checks that are running by default, and a lot of them are actually Google specific. Like, we don't use Guava, but there are like ridiculously complicated checks that will check like how do you use Guava without even checking if you have Guava in the first place, and they will check like every statement in your code. Do you use protobuf? Well, actually now we do, but still, like, do you use truth instead of assert or something, like, and whatnot? Like, some checks are just seems to be written overcomplicatedly. So yeah. Anyway, so how do you go about fixing something like this, which is maintained not by you, and the project is really large, so you don't really want to spend time? Like, I didn't even want, like, I just wanted to integrate Nullway, okay? Like, I didn't want to deal with ERPRON, to be honest. So disabling all the checks still doesn't fix the issue, right? Okay, what to do? First of all, you need to talk to someone, because there might be a chance that you're insane, which in tooling happens all the time. But then, if you think that you're not insane, you probably need to create a reproducible, isolated sample, ideally with containers and stuff, so that other people can run it on their machines without setting it up. You actually want to run it on different machines to see maybe it's machine-related, maybe it's macOS or Linux or whatnot. Okay, you're probably not insane if this is all reproducible, right? First of all, report to upstream. Like, don't spend months on that, dealing on your own. But turns out, Google people, like, if you even report this to upstream, they might be like, oh, no, this is only for you, you know, like, we don't see it in our setup, obviously, which was actually true in this particular case. Because, like, at Google, they compile everything with ERPRON. This is the default compiler, and I was like, am I about to fix Google compile times 3 times, 3.5 times? Would that save them billions of dollars? Would they pay me at least something of that? All of that didn't happen, except that it sort of did, but not for Google. So ERPRON was fine. Turns out the problem was in the ERPRON Gradle plugin. This plugin is not maintained by Google. In fact, it's maintained by a certain person, T. Brewer. So, like, and it's obviously under Apache 2 license, which clearly says, like, this has no guarantees, like, we are not responsible for anything, like, and if you spend, like, 3.5 times slower, you know, like, more time on your compiler, that's, you can't blame them, and which is fine, which is what open source for. Turns out that it was creating a new class loader for every time you would use ERPRON in a module, which pretty much disables just-in-time compiler for Java. So for just-in-time compiler to be able to keep the previous optimization set figured out for your code, it needs to know that the class loader didn't change, even if you load same classes. Took me a month to figure this out, unfortunately, but I mean, I didn't go insane, but I was about to go insane. But anyway, so this fix alone saves us around 166%, which I guess is 3. It's not 3.5, right? It's 2.5. Anyway, what does it say? Baseline. Yeah, so this is optimized version now, which is much better than it used to be. Still could be closer to that, but yeah, if you can fix that, you will save a lot for Google. They will not pay you anything, so I'm not sure you should, but yeah. So now we can continue with your Nullway integration after a month or so. And first of all, most of the tooling that we enable nowadays for static analysis, we only care about errors because no one looks at warnings, unfortunately. The good strategy about that, in many tools you can override the level of warning, and like the warnings you care about, you can propagate as errors. And we do that, for example, for Kotlin compiler. So we run Kotlin compiler with an option to fail on warnings, which is funny because we have a lot of deprecated methods, and deprecated are warnings. So people are not allowed to use deprecated code in Kotlin, which is actually kind of cool. Like it creates chain reactions, and like PRs are ridiculously large because of that. But we get rid of deprecated code that way. We also, as I mentioned, we had to set up an exclude list to enable it per module because we can't spend months to fix everything existing violations. And yeah, we enabled it for core modules and all that. Yarpron is also, nullWay is also sort of aware about some expected null cases in the JDK and Android SDK, which is really good. But it also, you can create like patterns for it to find, like for example, I don't know, we have like a custom view controller setup where these methods are expected to work with like class fields without fields having to be nullable, right? So like they will be like sort of late in it or something. You also want to talk to the people about how to use this thing, or at least what do yars mean, because, well, they see them now. Okay, so let's go to the other part. Yeah, every slide will contain some bad formatting, so it's up to you to find it. So how did we, well, okay, no, what does it say? Yeah, ideally code formatting should be configurable and flexible. It should be consistent with IDE, which in our case is, you can think that it's Android Studio, it's not, but you can imagine. And it should be executable from command line so that people who use Vim or some other text editors can benefit from that too. It should be fast, and it should be isolated from local environment. By that I mean that you don't have to have like specific version of Java or something. Like it should just work for most of the people. And of course, there is no solution out of box. So we had to build one, but sort of build. So what our code formatter does, yeah, I would love to show it to you, but yeah, I forgot. But if you run it first time, it would be something like, oh, I'm downloading IntelliJ IDEA Community Edition. And it's like around 500 megabytes, like don't freak out. And people do. And like recently we were on Caltrain with one of my colleagues and it started to download it because it was a new laptop. But anyway, it's a separate installation of IntelliJ Community Edition, which is then pretty heavily customized in terms of settings and plugins it has to run faster. So it downloads that, it removes plugins that come with IntelliJ because we don't want to pay startup time. It installs some plugins to format more languages that we want. It sets some custom VM options and whatnot, and it also sets this idea.properties to isolate from existing installations of IntelliJ, because otherwise they just auto-discover some other installations and their settings. And then we point it to our code style settings that we have committed in our project, so that in the end what you get is very consistent code formatting with how it uses exact same code styles that our IDE use, which is perfect. And the way we integrated it is through git commit pre-commit hook. So whenever you commit code, we format the files that are about to be committed. And that way it works for everyone, no matter where they commit from. It could be IDE, it could be terminal, it could be whatnot. This is how it looks like. You commit something, and then it starts IntelliJ, and then, yeah, it formats the files. So in our case, it works against Java, Gradle, or Groovy in general, Kotlin, properties files, because IntelliJ supports them. Docker file is not formatable, unfortunately, by IntelliJ, but the cool part about that is most of the time, when you install a separate plugin support, like language support in IntelliJ, it will be able to format that, and that is integratable here. The only problem right now is that it's kind of slow, because, well, it starts IntelliJ, and then it closes it. It would be ideal if we will be able to reuse running IntelliJ, because, well, people run IntelliJ all the time, right? Unfortunately, if you remove the IDEA properties, it will auto-discover that you run another IntelliJ. And in the terminal, it will say, you cannot run me from terminal if you're running in as GUI. And in GUI, it will pop up a dialog saying exact same thing. So I don't know why, but, well, yeah. Idea of that setup is that we will hopefully open source it soon, and all of you guys will be able to fix it for us. Maybe by patching IntelliJ. I have some ideas mentioned here. OK, yeah, here are the ideas. So yeah, it typically takes about 6 seconds for us, sometimes a bit more, sometimes a bit less. Actual formatting is super fast. That's why I'm asking you to optimize it. Actual formatting finishes in milliseconds. It's just IntelliJ starts up, like, and if you look at the logs, it's like starts an HTTP server or something, like whatnot. So there are a couple potential fixes that could solve that. Java, since Java version 9, Java supports ahead-of-time compilation, pretty much same how Android does it, and it can optimize for startup time specifically. The only problem is that reflection kind of not working in some cases, so it might fail on IntelliJ, but still. Another potential fix is that right now it seems that IntelliJ is just not optimized for this particular use case where you call formatter directly. It still like loads the project model and all that. I think it can be skipped. So as a result of that, we have around 300 plus KT files now, almost 20,000 lines of Kotlin code without comments. 56 modules of our project use Kotlin, and well, I write tooling in Kotlin. This is not all of that included. So yeah, that was pretty much it, our story. And there's a lot of like how people parts of that equation are really hard. Like this will take more time than tooling setup. Yeah, thanks.